Hello, we're going to take a close look at the Logix 1 Minute Engineer. But first, a general word about engineering. Engineering in the world of insulated concrete forms is basically the calculation of the amount of steel reinforcement bar that should be in the walls in order to give the walls the sufficient strength to support the loads that the walls have to support and to resist cracking. Now, Logix has developed a set of prescriptive engineering tables, which you can access. We're on the Logix Pro site, logixicf.com right now. We click on this link here, Technical Library. Right here at the top are the two prescriptive engineering documents that Logix has. Let's select the US engineering document, and it pops right up. As you can see, our prescriptive engineering tables are stamped by a licensed engineer, and so these should be accepted across the USA, in all states in the USA. Now, this engineering has been designed with certain building parameters in mind. These parameters are sufficiently generous that likely 80 to 90% of the homes being designed with Logix will fall within this engineering. So essentially, what this engineering does is it allows you to determine the correct engineering, the correct amount of rebar in the walls, the Logix walls, without having to go to a licensed engineer, engage them, spend the money with them to get them to do a site-specific engineering. This can all be done. You can save the money and just do it using these tables. Now, the only negative is, of course, these tables. There's a number of them. You have to know which tables to go to and how to pull the information out. But in relatively short order, you should be able to figure all this out. To make it even easier, Logix has created the Logix 1 Minute Engineer. So let's go back to the Pro site. And let's look at the top navigation bar once again, and you can see the 1 Minute Engineer. So we click on that, and it loads. And once again, we have to pick between Canada and the USA. So let's pick the USA. First question it asks you is select the rebar grade. Let's select 60 because that is the grade most commonly used. So now we are in the Logix 1 Minute Engineer. So let's look at doing the engineering for the below grade walls, and then we'll take a look at the above grade walls. So let's start with the basement. Let's assume we have a basement. We'll call this the test house. And let's start with the basement. So you have to say, first it pops up and it tells you the design parameters from the home. It's got to be at most 80 feet by 40 feet. Maximum roof clear span is 40 feet. Maximum floor clear span is 32 feet. And the number of stories is restricted to 2 above grade stories plus a basement. So our home falls within that. So let's click here and let's get going. So for the basement, we can select the core thickness of the Logix walls. In this case, let's select our 8-inch concrete core. Let's say that in this house, we're going to have 9-foot high walls, and we're going to have a backfill height of, say, 6 feet. So we'll have the 9-foot walls, 6 feet backfilled. The top 3 walls will be above grade. We have to select the equivalent soil density. Let's select 45 here. For guidance on this, Logix has prepared a table that can guide you as to which equivalent soil density to select. This is table 6.3 in our engineering documents. You can get that in our technical library. So now we have to decide the wall type above grade. It's either going to be Logix ICF walls above grade or wood framed walls above grade. Let's assume we're going to the roof with Logix, and we're going to call this the basement. All right, so we've loaded in our data, and let's hit preview. And this, our engineering pops right out. In this case, we're going to need number 4 horizontal rebar in the basement every 32 inches on center. That's every second course of Logix block. And we're going to need vertical rebar, once again, number 4 bar every 48 inches on center. And it also gives options for other different thicknesses of vertical bar. And it refers you to the exact chart and page of the Logix prescriptive engineering that you can reference to. Now, if you want to provide a report, download a report, you just click here on the report, It'll ask you, yes, I want to download it, and you open that. And here is your engineering report that you can print out, and you can now submit this or email this to your building official, and your engineering should be good to go. So we've done the below grade walls. Let's do the above grade walls. So let's say for the above grade walls, we can choose this time between the 4-inch core all the way up to the 12-inch core. So for the above grade walls, excuse me, let's select our 6¼ inch wall thickness. Let's say this is a ranch bungalow. We're going to have 10-foot high walls, and it's a ranch bungalow, so it's going to support the roof only. So we had our choices here. It could support a 2nd-story wood frame, a 2nd-story Logix, or more than 2 stories. We're going to say roof only. This is a ranch bungalow. So we have to now click on our location. Let's just say that we're in the state of Texas, and you can see that the wind load is automatically selected for you. So if I had selected, for instance, Virginia, that would have selected 60 pounds per square foot wind load, but we were in Texas, and so it gave us a value of 80. So you don't have to put that in manually. The 1 Minute Engineer does that for you. The wall type below is a below grade wall, and so we're going to call this the main floor. So we click on preview. Once again, our reinforcement bar is number 4-inch bar, every 32 inches on center horizontally, and the vertical bar above grade is going to be number 4, this time 32 inches on center. Once again, the table is referenced, but if we do want to print out a report, we just simply do so. And once again, we open it, and here's the report for the above grade walls. That similarly you can print out or email or save and send to your building officials as needed. Okay, so let's go back. That's your walls. You've just done the engineering for your below grade and above grade walls for your home. Now let's take it one step further. Let's talk about lintels. Now lintels are the beam, the structure that you're putting over top of an opening. It would be a door opening, like a garage or a main floor door, or it could be a window opening. And essentially, what the lintel does is you place the lintel over top of the opening, and it's designed to replace the strength that wall has lost when you remove the wall area of the opening. You create the opening, you remove concrete, and so you've got to make up for that lost wall structure, and that's what the lintel does. And in our engineering documents, we've got guidelines as to how to construct the lintels, but once again, you have to know how to navigate through the tables. So it gives you the lintel notes right here. We'll click on that. So let's say we've got a window on the main floor. It's the living room window, and so the wall side, the wall thickness is going to be our 6¼ inch, because that was the thickness of the wall that we selected for the main floors. So let's say the lintel depth. So this will be the depth between the top of the window and the top of the wall. So let's say the lintel depth is going to be, in this case, 12 inches. Let's say we've got a foot between the top of the opening and the top of the wall. And let's say it's a wide opening. Let's say it's a 6 foot wide window. The type of load, let's just say, well, it's not a point load. It's going to be a uniform load, because there's nothing over top of it. It's just the roof. Now it says, what's the factored load that's going to be on the lintel, and how do we know what it's going to be? So we'll say lintel load unknown. Well, so that now it asks us, is the load from? And we're going to say it's from the roof, and we're going to say the span of the roof was, let's say it's 20 feet, and that will automatically calculate the loads and that you have to factor in. And we're going to say this is a living room window. And let's hit report. And here is your lintel design for your living room window. The lintel has been designed. It's going to have a top bar of a number 4 bar. It's going to have a bottom bar of a number 5 bar, and it's created your lintel for you, and it's actually referenced the table, the lintel table, and you'll see that there's no stirrups required in this specific lintel. So this is your lintel designed instantaneously with the Logix Engineer. It's just a tremendous time saver. Now, you can access the Logix Engineer. Let's go back here. You can access the Logix 1 Minute Engineer on the Logix website. This is our online version. However, you can also download a desktop version. If we go to our support section in the logixicf.com, you can see the software solution and apps page, and you can see here where you can actually download the desktop version of the 1 Minute Engineer. It is only available in PC. It's not available in Windows. If you're a Mac user, then you best use the online version that you can access right off the Logix website. But for even more convenience, you can also use the Logix 1 Minute Engineer on your mobile device, either your phone or your tablet, and you can download it here. It's either an Android format or an Apple format. You can download it here. So you can actually be on the go. You can be on the job site and confirming lintel details, confirming engineering. So you can be anywhere and access the convenience of the Logix 1 Minute Engineer. All right, well, that's the overview of the Logix 1 Minute Engineer. Logix is the ICF solutions company helping you to build anything better.